Hello friends, Pushkar here, back again with another video. In this video, I will solve a LeetCode problem named find peak element. So this problem has been asked in companies like Google. So without any further ado, let's get started. So let me first explain you the problem. So in this problem, you have to find the peak element. Okay, so you are given an array of integers and you have to find the peak element. Okay, for example, in this example, you are given an array nums, okay, which has value like 1, 2, 3 and 1. Okay, so integer neighbor is basically the adjacent element. So for example, in this array, the neighbor of 1 is 2, okay, and the neighbor of 2 is both 1 and 3, and the neighbor of 3 is both 2 and then 1, okay, and the neighbor of 1 is only 3. Okay, so a peak element is an element which is greater than both of its neighbor. Okay, so in this example, only 3 is greater than both of its neighbor, that is 2 and 1. So you have to return the index of the element. Okay, so the index of 3 is 2. Okay, as you can see in the explanation. Okay, so and in the second example, okay, so you are given an array with that contains a value like 1, 2, 1, 3, 5, 6, 4. Okay, so basically you are given an array like this. So here I can see the number 2 is greater than both of its neighbor, that is 1 and 1, and again the number 6 is greater than both of its neighbor, okay, that is 5 and 4. So here the anyone is your answer. Okay, so for example, you can return either 1 or 5. Okay, the 1 is the index of 2 and 5 is the index of. Okay, now how to solve this? Okay, so one simple solution is iterate over the list. Okay, and for each element just check whether it is greater than its previous element and the next element. If it is greater than both, then this is your answer. Okay, but the time complexity of this will be order of n. Okay, but can we do it little bit better? Okay, so yes, we can do it in a better way. So in fact in a more optimized way, if we use a binary search. Okay, because we can see so if I represent this array, okay, in a chart format, okay, so something like this. Okay, so I have 1, okay, then 2 is greater than 1, okay, then 2, then 3, then 5, 6 and 4. So basically something like this. Okay, so at the end you will for basically an array of integer can be represented as you can say in terms of mountains. Okay, for example, here you can see this is like this. Okay, and here two possible answer. This one is greater than both of its neighbor and this one greater than both of its neighbor. So in this example, it is 2 and 6. Okay, so suppose we are given an array something like this. Okay, so we will use a binary search to solve this problem. Okay, how we can use a binary search for this? So for example, if I have, let's say the low is 0 and high is the array length -1. Okay, and let's say mid comes here. Okay, not here, let's say mid comes here. Okay, in the binary search. If you're not aware of binary search, you can watch some tutorials related to binary search. Okay, so here, so you can see that you are lying in this path. Okay, so one thing is sure, since that if you are like in a slope of inclined, okay, then your answer will be in the right side. Okay, and suppose if your mid is in this part, okay, like this part, okay, then your answer will be the left side. Okay, so yeah, so basically, so your logic will be like this. If your array of mid, okay, is a less than, okay, if it is less than its next element, okay, less than array of mid plus 1, okay, this means you are lying in this part. Okay, then what you can do is, you know that your answer should lie in the right side of the array. Okay, that is from here till here. Okay, so your new mid will become, not your mid, basically your low will become mid plus 1. Okay, else you are lying in this part. Okay, so here your high will become the mid. Okay, and at the end you will return the, basically when you're left and when you're low, when your low and high becomes the same, that is your answer. Okay, so you can return the left. Okay, so I hope you get the solution of this. So let's start the implementation part. Okay, so let me a little bit zoom the Chrome. I think this is enough. So okay, so let's say we have integer low which pointing to the lowest possible value, and we have int high which points to the highest possible value, that is nums dot length minus 1. Okay, and while your low is less than the high, you can continue. Okay, and you should break when your low is equals to high, because that is your answer. Okay, so int mid is equals to, take something like this, low plus high minus low by 2. Okay, and now our logic. Okay, that is this one. Okay, so if nums mid, okay, if it is less than nums mid plus 1, that means it is lying on the inclined slope. Okay, so your new low will be mid plus 1. Okay, because your answer will lie in the right side of the array. Okay, and else your answer will lie on the left side of the array, mid. Okay, and this will break when low and high become same, and you can then simply return. One thing is sure, that the loop will break when both low and high are same. Okay, so you can return any value like high or low. Okay, let's return the low, and now let's run the sample test cases. Let's see whether it passes or not. As you can see, it has accepted the sample test cases. Now let's submit. Okay, as you can see, it has accepted, it has passed all these test cases, and the solution is accepted. And you can see this solution is 100% faster than, basically the solution is faster than all of the solutions that has been submitted. Okay, for Java programming language. Okay, this is what in this video. If you like this video, then you can subscribe to my channel. I will be posting like a regular LeetCode problems in this YouTube channel. Okay, till then, bye.